When converting between rectangular and polar coordinates, it's helpful to memorize a few formulas. So we know that if you have a rectangular point x, y, and an equivalent polar coordinate r theta, that r squared is equal to x squared plus y squared. Furthermore, we know that tangent of theta is equal to y over x, and that x is equal to r cosine theta, and y is equal to r sine theta. Alright, there are all of our equations. Now, only two of these are really helpful because here we're given a rectangular coordinate and we're supposed to turn into polar, for which these first two equations are really helpful. Alright, one thing I want to point out before we get too far into this is that r is less than 0. That's one of the specifications for the point they give us. In order to account for this, when we calculate r, we'll make sure it's negative, and we'll have to fix our theta, because recall, a negative r on a polar coordinate brings it across the graph. So for instance, if you have a theta that's up here, normally you would go out in that direction to find the point. However, a negative r tells you to go the opposite direction. And usually this can be done by a simple addition or subtraction by pi. Alright, so what we can do then is first find r. So we see r squared is equal to x squared plus y squared. So r squared is equal to, here our point is 3, negative 3 square root of 3. So we have 3 squared plus negative 3 square root of 3 squared. Note that when you square a point like this, when you square a number that has two terms like this, two factors, you can square them independently. So we have 9 plus 9 times 3. 9 times 3 is 27, plus 9 is 36. Since r is squared, however, we have to square root it, and we get plus or minus the square root of 36, which is 6. And here's where we can choose the negative version. So I can ignore this positive version here, and r is equal to negative 6. Now we have to find our theta, but keep in mind that once we found our theta, we have to turn it across the unit circle. So we know that tangent theta is equal to y over x, so it's equal to, for us, negative 3 square root of 3 over 3, which is just negative square root of 3. Alright, knowing that, we can take a tangent inverse and get theta is equal to tangent inverse of negative square root of 3. And if I perform this tangent inverse either with a calculator or if I look at the unit circle and find a point that has a y value, or excuse me, y over x, a tangent value of negative square root of 3, I'm going to go to the fourth quadrant, and specifically the negative first quadrant, and find negative pi over 3. Now this is almost the point we want. Notice that our coordinate 3 negative square root of 3 over negative square root of 3 ends up in the fourth quadrant. Right? So we end up with negative pi over 3, or if you put it into the unit circle, it would end up being 5 pi over 3. But the point being is that since we have a negative r, we actually have to move this theta across the unit circle. And like I mentioned earlier, we can do that just by adding pi. And that will give us 2 pi over 3. Since we have our r and we have our theta, we can write them in our point, and that would be our final answer. Negative 6, 2 pi over 3.